And in this talk, I'm going to take you on sort of a journey through different physics learning contexts, from lower secondary school up and into higher education, with a little glimpse also into the learning of professional physicists. We're going to stop on the way and pick up some theoretical concepts to make sense of these different learning contexts. But for a talk in a section that's called theoretical frameworks, it's actually not going to be that theory heavy. I'm assuming that is perhaps a relief to some people in here, and a disappointment to some others, but that's just the way it's going to be. So, I'd like to start by asking you to think back to your lower secondary school physics classroom. There are different names for this level of schooling in different national contexts, but I'm thinking about sort of the last years of compulsory schooling, ages sort of 13 to 15 approximately. That last time you were then probably taking physics. For some of you, that might be the last time you were actually taking physics. For some of you, that would have been the last time you were taking physics together with other students who had not chosen to specialize in physics or specialize in science. What are your memories from this school physics classroom? I guess this classroom is in some ways very similar to other classrooms. The setup is probably similar, with the teacher's desk and the student desks in rows facing that teacher desk, thereby also then facilitating particular types of student and teacher interactions and avoiding too much student-to-student interaction. But there are also ways, I guess, in which this classroom differs from other classrooms in that school. Maybe there are, like in this photo, glass cabinets along the walls filled with laboratory equipment that might fill you with either excitement or fear. How are you feeling in that classroom? For many of you in here, it might be a feeling of belonging. Maybe also a feeling of success, when you actually were able to, on your first try, make all those light bulbs in that kind of complicated parallel circuit light up at the same time. But look around in that classroom. It's also likely to be other classmates in that classroom who may be looking dreamingly at the clock on the wall, wishing for nothing more than that it could move just a little bit faster. Hopefully, both you and your classmates in that classroom are learning a thing or two about physics, but you're also very likely to learn whether physics is a subject for you or not. And in many, many schools, or many students actually learn that physics is not for them. It's a subject that generally is perceived as difficult. And when we talk about physics as a hard science, this predominantly, of course, refers to the perception of, or the idea of the knowledge being produced, and how that knowledge is, as Alexandra was talking about previously, seen as objective, neutral, universal. But this might also contribute to the perception of the discipline being hard, as in being difficult, not for everyone. So physics is also strongly aligned with notions of cleverness, notions of intelligence, also aligned with men and masculinity to a large extent. But why does then school physics do all this work, seemingly to keep people out? Because it seems like that, really. Like it's doing a lot of work to keep people out. Louise Archer and colleagues, they argue that the purpose of pedagogic work is the reproduction of dominant relations of privilege and inequality. And in the case of physics then, they further argue that we can understand this pedagogic work as being enacted within school physics in order to maintain then a certain order and to maintain the dominant status of this discipline. So consequently, classroom practices that in various ways then align physics with cleverness, or that continuously defer like the interesting bits of physics to a later stage, they aren't just seen as randomly happening. They play a key role in reproducing physics then as an elite subject by restricting both the number and the diversity of whom is entering into this profession, of whom in that lower secondary school physics classroom see themselves as possible to engage with this discipline. So through such practices, physics then is able to maintain this high status in relation to other subjects generally, but also in relation to the other science subjects specifically. So at the same time as students are learning physics, or maybe not learning physics, in that lower secondary school physics classroom, they are also participating in the production and reproduction of cultural notions of physics, and forming their own identities as learners of physics in relation to these cultural practices. So we can think of the learning going on in that physics classroom, or in any other classroom for that matter, as also involving components of identity formation. Heidi Carlone and Angela Johnson, they write about this as follows. They write that identity is not simply what an individual says about her relationship to, abilities in, or aspirations regarding science. Identity arises out of the constraints and resources available in a local setting. What different ways of being a physics student are available in that lower secondary school physics classroom, or in your physics classroom, for example? I assume many in here also working hard to kind of break these cultural notions of physics as being hard, or as physics as being just for people with some sort of innate talent, for example. They continue. Identity is not just something an individual feels, it's not even what an individual does, although feelings and actions are components of identity. A science identity is accessible when, as a result of an individual's competence and performance, she is recognized by meaningful others, people whose acceptance of her matters to her as a science person. So the key here is performance and recognition. So it is what you perform in a classroom, for example, or a lab setting or somewhere else, but it's also how that performance is being recognized. So what can this process of performance and recognition look like? I'm going to share a very quick, simple example from an upper secondary school physics classroom. This is a lesson about mechanics, not quantum mechanics, you might be relieved to hear. It's a lesson about mechanics, more specifically kinetic and potential energy. These students are 15, 16 years old. They've done a very simple lab exercise. They have let go of a ball from a certain height and then let the ball bounce and measured how high it bounces back. And the teacher then asks the students about the relationship between kinetic and potential energy of this bouncing ball. And Esther, one of the students, raises her hand quickly. And when she replies, she says a few things, but mainly she replies with a gesture of her hand, showing how potential and kinetic energy varies as this ball falls. The teacher is very happy with Esther's explanation. She shows this in her body language, how this was an excellent way of answering this question, in a way that obviously wouldn't have gone well on a written exam, for example. But here it works well. The teacher says, that was a really good, even I have nothing to add to that. It goes like this, you get it, that was a really good explanation. Then she repeats Esther's hand movement in front of the whole class. So this classroom, the classroom of the teacher Ann-Sophie, is a classroom where solutions to problems can be neat. She says that a lot, the solutions are neat. And aesthetics and emotions then are also recognized as part of a physics practice, and students are recognized for performing those things in this classroom. So in this upper secondary school physics classroom, some students also learn that physics is for them, as Esther is doing here, for example, as she is recognized as someone who gives a really good explanation. And some of them, not Esther though, but others will continue to higher education physics. And next we will look into some student trajectories into higher education physics. Some unexpected student trajectories into higher education physics through the lens of choice narratives. And a choice narrative then, these are stories we tell about our way to a particular education or a particular profession as means of justifying the choices we make, both to ourselves but also to other people. And in this case, with the choice narratives I'm going to show you today, these are constructed from something we call timelined interviews with first and second year physics students at universities. And these students that have been interviewed, they have responded to a call from a study that is interested in the trajectories of students from unexpected physics students. So these are students who in some way self-identify as being unusual in the kind of learning context they find themselves in. So students who replied to this call were women, there were students from non-academic backgrounds, students from migrant backgrounds, minoritized ethnic backgrounds, and sometimes all three at once. And during these interviews, the students then, together with the interviewer, constructed timelines on a very practical way on a big piece of paper, or in later cases on Zoom, because that's all we could do then. Outlining then important occurrences and important people on these students' science of physics learning trajectories. And our analysis, or part of the analysis of these timelined interviews, has then gone into identifying choice narratives in these timelines. And this is a concept from Henriette Holmgaard and colleagues, who suggest that such choice narratives, they need to be recognizable, that is, they need to be legible in a particular discursive context, but also that there are expectations on our choice narratives to be personalized, since there are strong societal expectations on us making free choices. But also, in some ways presented as being natural or suitable for us, and preferably not too predictable, because remember, we want them to be personalized. We want to in some way be able to show our individuality. I'm going to give you an example of that just shortly. So the narratives also need to be presented in a relatively coherent way to kind of make sense in this context of the interview. Aligning them past, present, and future. This is not to say that they cannot be reworked along the way, they definitely can. So the choice narratives we have identified could be said to be kind of students' current justifications of their choice of physics education, and they're not necessarily super stable over time. Looking at the empirical data as a whole, that is 21 in-depth interviews with university physics students, we can see three main motivations for why students go into higher education physics. Not unexpectedly and very predictably, interest in the subject is one of them, but also the prestige of the education, and maybe more unexpectedly, the possibility to make a contribution. I'm going to go through these three in turn, but first we're going to take a brief look at the entire group of interviewed students. So this is everyone, the 21 students we've interviewed, kind of a brief overview of who they are in terms of social class background. So you see the program, they're either doing Bachelor of Science programs or they're doing engineering physics. Something about the national background, something about the place they were from, and the kind of narratives that figure in their interviews. names here, pseudonyms, obviously. As you can see, interest is a strong one. A filled circle means that this is a real core narrative in the student's story. An unfilled circle means that this is a choice narrative that figures in the story, but might not be at the core of that story. The small wiggly ones, well, we aren't done analyzing those yet. So what you see here is actually work in progress. But as I said, not surprisingly, interest is a strong choice narrative. This is something that is shown in almost all the student narratives. And this also mirrors a lot of previous research around why students go into higher education physics. And also, you could say, it's very much part of kind of the script for a physics person. Katrin Hasse writes about the idea of the childhood physicist, how you can also actually make yourself kind of a legitimate participant in this discipline, perhaps especially as a minoritized physics student, by constructing your story as you've really always been a physicist. You were stargazing as a child, you were playing with physics toys, you were doing small lab experiments in your parents' basement. All of this can then feed into the story of why you, as someone who is in some ways an unexpected physics student, is the real deal, is the authentic physicist to be. And some students also work very hard to narrate their story as a personalized, independent choice narrative. Stella is one of them. Both her dad and her grandfather have been working as space engineers, and she is studying astronomy herself. She says, people always say you'll become like one of your parents, but I don't want, like this, but my dad is a space engineer. Then it's like, yeah, but then it's obvious that you're into space. But I'm like, I actually discovered this all by myself. And then she tells a rather elaborate story of how she was looking for inspiration for a painting she was doing, Googled the word astronaut, and found really interesting pictures of space, and that's how her interest in space picked up. So she's doing a lot of narrative work to construct this independent and personalized choice narrative. Interest might be the obvious thing you think about when you think about why someone chooses a particular education, and then you would probably imagine that people would be choosing between educations that are quite similar to one another. That's not always the case. Alva here, she was choosing between becoming a doctor or doing engineering physics. So two quite different educations, but what they have in common is that they are prestigious educations. This is a choice between different elite educations. She continues, I decided between engineering physics, an interdisciplinary engineering program, or chemical engineering. But I choose this in the end anyway, because it's the broadest and you get the most choices and, yeah, prestige. Now I'm completely honest, she laughs. There's prestige, absolutely, in it. And this is also a recurring kind of narrative we see among the students, who are then not predominantly motivated by interest. A perhaps more unusual motivation for studying physics, but a very strong one in the narratives where we do see it, that is choosing physics because it enables students to in some way make a contribution either to society or to their kind of some sort of home community. There is Hanna, who has a migrant background, who migrated to Sweden in the early teens, who talks a lot about the chances she has gotten in Sweden and through the Swedish educational system. And now she wants to give back, and she wants to help others to have the same opportunities that she had. She even has kind of far-reaching plans. This is a first-year physics student, by the way. She has far-reaching plans of trying to, in the future, establish an institute for physics and physics education in her parents' home country in order to give something back to that community. But then he might be taking a somewhat more instrumentalist view in this, and well, science and technology are a very effective way of making the world better. This is not so often highlighted as a motivation for physics in previous research. And so in some ways, this might also be clashing with this expectations within physics on that purity, neutrality of the discipline. You should really be in it for its own sake, shouldn't you? Not for the sake of contributing to a home community or whatever. As a woman in the discipline, it might be even easier. You can make a contribution just by being there. This is Stella again. Stella says, if someone asks, what are you doing for feminism? I'm a physicist, like. I think it's quite fun. I'm here and I disturb things a bit. That's great. I'm very satisfied with it. So just by being there, Stella is able to make a contribution to feminism. And this, of course, is very much a sanctioned discourse, and it has benefits for her, and she gains recognition also for this. And as I said, we don't see this in that many of the stories, but when this choice narrative is narrated, it is often then in relation to a marginalized gender, class, or ethnic migrant position, and it is a very strong narrative in those stories. So these were some of the motivations the students might have for going into higher education physics. But when they enter that context, when they enter the higher education physics, what do they meet? Well, most likely they meet a strong sense of community, also glued together by long teaching intense days. They are likely to spend a lot of time in the physics department. They meet expectations of being able to perform mathematical manipulations of physical laws, but probably not as strong expectations on the conceptual understanding of those mathematical manipulations they've just been able to do. And physics is also, going back all the way to Descartes, I guess, presented as the most fundamental of the sciences, a richly rewarding adventure, appealing to their rational intelligence as well as their sense of beauty. But what might this look like in the physics classroom, university physics classroom? How is physics presented there? Or rather, can we think about how is physics performed in that classroom? Now it's quantum mechanics. This is the first lecture in the course of Introductory Quantum Mechanics, and among other things, the teacher is introducing the Schrödinger equation. And during this lecture, the teacher focuses a lot on how strange quantum mechanics is, how the world at the quantum scale behaves nothing like what we're used to from our everyday experiences. And the teacher, she has just discussed that what quantum mechanics can give us is the probability to find a particle in a certain interval. We cannot actually know where that particle is. And then she goes on and talks some more about this, and then she says, how many find this to be counterintuitive and weird? As an observer in this classroom, you kind of sense that she wants a lot of hands raised. She don't get that. One student raises their hand. She says, those of you who don't raise your hands probably need to give this some more thought, because this is weird. So quantum mechanics is supposed to be incomprehensible. Don't worry if you don't understand. Don't worry if you don't understand. At least not right now. And in this classroom, also repeated references to Albert Einstein, to Niels Bohr, to the Nobel Prize. It can create this feeling of belonging to something that is very special, very exclusive, not for everyone, but for you in that classroom. So the teacher can also be thought of as constructing then a physicist community, sort of a local culture, where students then, of course, are expected to be able to reason and also do calculations using Schrödinger equations, for example. But they're also expected to be fascinated by, rather than frightened by, this presentation of quantum mechanics as mysterious and weird. So as a university physics student, you find yourself then in a world, a culture, a community, if you wish, with certain customs and habits, where certain ways of acting and being are encouraged and foregrounded, and others are not. And the students are navigating and also, of course, producing this cultural world of which they are a part. And as they are doing that, as they're navigating this and producing this cultural world, I would argue that they're not just doing physics, they are also doing gender at the same time. And we can think of just as physics being performed in that classroom, we can also think about gender as something that is performed, something that is performative. And this is a very different way of thinking about gender than how we think about gender in our everyday life, and how we often also measure gender in terms of those boxes we can tick in with man, woman, non-binary, etc. And kind of everyday notions of gender as something you are. But we can also think about gender then as something that's performative, and that's also enacted differently in different contexts. You enact it differently in this conference than you maybe do in your home research environment, and definitely different than you do at home. And we can think of gender as being performed in a number of different ways, through behavior, stress, speech, but also things like career choices and interests. And of course, this is somewhat limited by the local context we find ourselves in. Different things are encouraged in different cultures and in different contexts. So from this perspective, gender is thought of then as relational, as local, and how gender is performed in different contexts, and looking at that also speaks to the potential of how that context then limits or enables certain identities, certain gender expression. And I would argue that this perspective of gender helps us then to look more carefully at the complexities of gendered experiences in physics environments, rather than simply asking questions about what women need to do in order to succeed in physics. Because those questions about what women need to do in order to succeed in physics, they invariably boil down to kind of stereotypical assumptions about how women work and how men work, and how women can change in order to be more like men. So moving away from kind of a binary and static view of gender can also open up for the kind of questions that researchers can ask about experiences of gender and how those vary across contexts. And we're going to have a look at this from the world of university physics teaching and learning. Laura, she's an undergraduate physics student in Canada, as it happens, being interviewed about her experiences of studying physics. And this interview has a particular focus also on gender. Laura says, I find it hard to talk to a lot of other women because their interests are so far from my own that we don't really have a lot in common. I'm not interested, I barely ever watch TV, and I always wear the same clothes. Like, all the new clothes I get are gifts that people give me, you know. My roommate had been cutting my hair for the last year, and before that I got it cut a year before, and I might get it cut this year. Like, to me, there's just not time for these things. But I find that a lot of women make time for these things, and I'm more interested in computer games and like. If I had to choose between getting my haircut and playing a computer game, I would pick the computer game or any other game, but not getting my haircut. I don't even like people touching me so much, something. Pedicures and nails, I hate all that stuff. So the first thing to notice here can be how Laura feminizes an interest in caring about appearance and style, and how she also positions this in contrast to playing computer games. So on very much a surface level, we can think of this as a doing of gender, how she positions herself in relation to other women, in relation to normative femininity. But taking a step back from her self-understanding, we can instead also look for the cultural logics that structure this utterance and make it intelligible in this context. First of all, we have this idea that physics is gender neutral. And this idea that physics is gender neutral actually gains strength from this type of distancing from the body and from style, thereby once again privileging mind over body, as Alexandra was talking about, and simultaneously then insisting that in physics it's reason, rationality, smartness, those are the only things that matter. However, manifesting this neglect of body and style is also very hard to do without simultaneously centralizing the body and centralizing aesthetics. The body isn't here merely made irrelevant. Rather, the rejection of the body here is central to making physics appear as a discipline where only the mind matters. And second, students not only distance themselves from and downplay the value of corporality and style, but in doing so also then positions these interests as feminine. So caring about style, caring about appearance simultaneously signifies femininity and signifies not caring about or not being passionate enough about physics. Thus, paying too much attention to style and corporal aesthetics, that is an action that can undermine the potential to be recognized as being then passionate about one's discipline. Of course, these are not things that Laura are thinking about consciously or doing in that moment. But Judith Butler would argue that people, consciously or not, are citing conventions of gender when they claim to be expressing their own interior reality, or even when they say they are creating themselves anew. It seems to me, she writes, that none of us totally escape cultural norms. So Laura here might be positioning herself in relation to cultural norms, might be distancing herself from normative femininity, but those cultural norms are still there, are still something she is working with in her identity constitution. At the same time, though, Butler writes, none of us are totally determined by cultural norms. Gender then becomes a negotiation, a struggle, a way of dealing with historical constraints and making new realities. When we are girlied, we are entered into a realm of girldom that's been built up over a long time, just the same way as the idea of physics has been built up over a long time, and that is also something we are entering into. A series of conventions, sometimes conflicting, that establishes girliness within society. We don't just choose it, and it's not just imposed upon us, but that social reality can, and it does, change. So looking at physics as well as gender as something that is performative also then opens up for the potential of change. And change is certainly needed. Otherwise we wouldn't even be at this conference, would we? Astrophysicist Chanda Prescott-Weinstein, she writes, I know this is a long quote, but it's worth it. I understand intellectually why my work on inflation and axioms is interesting, but I'm tired of the disjointed feeling of liking the ideas but finding it hard to breathe in the community in which I have to share them. Because I am human and not an objectivity machine, those two things are both part of doing science. Astrophysics loses so many people, including white men, because the community refuses to acknowledge this dual reality, that science is both a mathematical process and a human social enterprise. Many of my colleagues refuse to consider what it's like for someone like me to watch the very few black people ahead of me, her in the pipeline, disappear from the mix. It can be hard to see the wonders of the universe through the social card. Yet, here I am. As unattractive as the professional world of physicists can be, I'm still completely dazzled by quantum field theory. Every year I feel like I'm learning particle physics for the first time, and it's still amazing. Space-time is still curved. I'm still more fascinated by that fact than I am horrified by all the terrible behaviors I witness from people who are expert on that fact. So the story about physics I've told in today's talk is a story of how physics can be dazzling, beautiful, wonderfully weird. But it's also a story of how the discipline is associated with a particular kind of cleverness, is seen as difficult, and thereby also gaining prestige. And how these different stories are interconnected and entangled, and also shaping students' and professionals' participation in the discipline. But what can we do then, in order for physics to be more welcoming? Well, as Chanda Prescott-Weinstein says, a starting point is to acknowledge that science is both a mathematical process and a human social enterprise. A study by physics education researcher Sarah Hazari and colleagues also showed that discussions of the disciplinary culture of physics can actually have a positive effect when it comes to encouraging female students to pursue careers in the physical sciences. So an awareness of this can have very concrete effects in terms of recruitment and retention. So in Hazari's study, they tested a number of common hypotheses regarding factors that encourage female students to pursue careers in the physical sciences. And perhaps surprisingly, no significant effect were found for example, having women teachers or women scientists guest speakers. But what did have a significant effect was discussions about women's underrepresentation. And on a similar note, we can think of, could maybe highlighting then more motivations for choosing physics beyond the script of the childhood physicist also lead to a more inclusive physics or science education? Because obviously there are women, quite a few in physics, as well as people of different ethnicities. There's queers, there are people with disabilities. But the conditions for them, for us, to reach our full potential, as the Pro Vice-Chancellor spoke about in the opening session, are hardly there as long as we cannot kind of shake that feeling of that we have barriers to break. Chanda Prescott-Weinstein again, she writes, "I wanted to be normal, but I felt I had to be extraordinary." Thank you.